Hello, in this video we're going to look at applying the half-angle formulas. So again, here are the half-angle identities, or the half-angle formulas. One thing you have to remember when you're working with these is that because you have a plus or minus, we have to know how to choose, well, is it the plus or is it the minus? And the way you choose depends on which quadrant the half-angle, the x over 2, actually is in, and then asking, is the cosine positive or negative there, or is the sine positive or negative there? So depending on whether you're taking the cosine or sine of that half-angle formula, you ask yourself, in that particular quadrant where the half-angle is, what would be the cosine or sine? Would it be positive or negative, right? All right, so the first one we're going to look at, use the half-angle identity to find the exact value of sine of 15 degrees. Now, one thing you'll see is a lot of, when they ask you these questions, they're giving you the half angle of something that you actually know, because we only know a few angles, right, the special angles. So notice that the half angle formula, when you actually go to apply it, you apply it on this side. You fill everything in here. And so notice that you're working with the cosine of the full angle, and you have to know that. So especially when they ask you find the exact value, that's not something you're going to put in your calculator. So really what happens is they give you half angles of where you actually know the double of that angle. So the double of 15 would be 30, and we actually know that. All right, so let's go ahead and write the formula we're going to use. It's going to be this one right here. We're going to use sine of x over 2 is plus or minus square root of 1 minus cosine of x all over 2, right? Using this. Now, since what we're working with is the 15, that is our half angle, we have to ask ourselves, 15 is in quadrant 1, 15 degrees is in quadrant 1, and the sine, which is the y-coordinate, is positive. So that's how we know to take the positive, okay? So now we're going to work with that, and the other thing I want to do is, so here's one little piece I want to work in before I actually fill everything in, is that remember, when I say 15 degrees, that x over 2 is 15 degrees, I can now multiply both sides by 2, right? And so my x is 30 degrees. All right, now we're ready to go ahead and plug everything in. So let me get a clean, fresh piece of paper. All right, so we're going to use that the sine of 15 degrees is the same thing as the sine of 30 degrees divided by 2, right? And that we know now is going to be the positive, right, of square root of 1 minus cosine of x, which is the 30, all over 2. Okay? So now we got to work with that. We just got to evaluate it and all that. So now we say, well, cosine of 30, right? We know our unit circle. And square root 3 over 2, 1/2. So the cosine is the x-coordinate. So we want the square root 3 over 2, right, at 30 degrees. So we're going to have then that this is the positive of 1 minus square root 3 over 2 all over 2. Now from here, it's a lot of algebra and arithmetic, and it is sometimes, you know, a bit hairy. So I want to get a common denominator here. So I'm going to say 2 over 2, right? 2 over 2 minus square root 3 over 2 all over this 2. Okay? So now I've got the same denominator, but I can't really subtract 2 and a square root 3, so I kind of have to just leave it. 2 minus square root 3 all over 2, and then all over 2, and the square root of that. So now this is really 2 over 1, so I'm going to flip and multiply and say that's square root of 2 minus square root 3 over 2 times 1/2. But remember, this is really 4. I'll go ahead and write it out. Normally, I don't think most people would. They would just kind of go ahead and take the 2 out of the root. But now the square root of 4 is 2. So what I'm going to be able to do is say that this is square root of 2 minus square root 3. Oops, let me not make that so big. right? That's the root all over 2. So the root only applies now to the numerator because the square root of 4 is now 2. So that is finally your answer. Okay? All right, so now let's take a look at another example. We're going to use the half angle identity now to find the exact value of cosine of 157.5 degrees. So again, we're going to use this formula now. So we're going to say cosine of x over 2 is equal to plus or minus square root of 1 plus cosine x all over 2. Now, here what we want to do is, again, say, well, first of all, the choice of plus or minus, that depends on where the half angle itself, which is the 157.5, you know, what is the cosine of that? Is it positive or negative? So if you look, you know, 157, I don't know, somewhere here, right? 0.5 degrees. So it's in quadrant 2, and in quadrant 2, the x value, which is cosine, right, is negative. So since cosine, or the x-coordinate, is negative in quadrant 2, we take negative of these two, okay? And the other thing I want to just mention is that x over 2 is 157.5 degrees. So I'm going to multiply both sides by 2, right? And then I'm going to get that x is 315 degrees. All right. Armed with this, we're going to go back and plug everything in here. So I'm going to say cosine of 157.5 degrees is the same thing as cosine of 315 degrees divided by 2, which is, now we plug it in here, we're going to take the negative of the square root of 1 plus cosine of the x, 315, so 1 plus cosine 315, all divided by 2. Okay. All right, so now it's a lot of, so one little piece of trig, which is right here. So let's go ahead and evaluate at 315, what do we have here? So we're here at 315, multiple of the 45 degrees, so you'll have square root 2 over 2, and the x is positive, and the y is negative. But we want the cosine, right? So we want this. So now I say negative 1 plus square root 2 over 2 all over 2. Now this is all under the radical so far. So again, we're going to go ahead and simplify by making this 2 over 2. Right? And now I can't really add, but I can at least put them one numerator, right? 2 plus square root of 2 all over 2. And then this is all still divided by 2, understood over 1. So now I can flip and multiply and say 2 plus square root of 2 over 2, and then times 1/2. This 1/2 came from this 2 over 1 where I flip and multiply. So now I have negative square root of 2 plus square root of 2 over 4. And again, the square root of 4 comes out as 2. So we'll have negative square root of 2 plus the square root of 2 all over 2. And that's your answer. All right, thanks so much for listening.